Want to master fraud detection using AI and machine learning? In this comprehensive tutorial, we'll guide you step by step in building a real-world fraud detection system from scratch using Python, machine learning models, and cutting-edge techniques used by top fintech companies. Whether you're preparing for a data science job, building a portfolio project, or aiming to deploy ML in finance, this end-to-end guide is all you need. Building a complete fraud detection AI system from scratch involves multiple stages, from data acquisition to model deployment. Here's a step-by-step guide tailored for a real-world scenario like credit card fraud detection or online transaction fraud detection. Overview: Key components. Problem definition. Data collection. Data preprocessing. Exploratory data analysis. Feature engineering. Model selection and training. Model evaluation. Model tuning. Deployment. Monitoring and feedback loop. Step-by-step implementation. 1. Problem definition. Detect fraudulent transactions in real time using historical transaction data. 2. Data collection. Public datasets. Kaggle credit card fraud detection. IEEE CES fraud detection dataset. Data features transaction ID, time, amount, customer ID, merchant, device info, IP, geolocation, etc. 3. Data preprocessing. Import pandas SPD. From sklern.model_selection import train_test_split. From sklern.preprocessing import standard scalar. df equals pd readif sv. Credit card.csv. Check class imbalance. Print df class dot value_counts. Normalize amount and time. Scalar equals standard scalar. df scaled_amount equals scalar fit_transform. df amount. df scaled_time equals scalar fit_transform. df time. df.drop amount time axis equals 1. In place equals true. Split the data. X equals df.drop class axis equals 1. Y equals df class x_train x_test y_train y_test equals train_test_split x y test_size equals 0.2 stratify equals y. 4. Exploratory data analysis EDA. Use matplotlib/seaborn for visualizations. Check for class imbalance, correlation between features, outliers. Import seaborn as SNS. Import matplotlib.pyplot as PLT. SNS.countlot x equals y. PLT.title class distribution. 5. Feature engineering. Time-based features, hour, day of week. Historical pattern-based features, average spending, frequency, etc. Anomaly indicators, e.g., unusual country or IP. 6. Model selection. Popular models. Logistic regression baseline. Random forest. XGBoost/LightGBM. Autoencoders unsupervised. Isolation forest/one class SVM. Example using random forest. From sklern.ensemble import random forest classifier. CLF equals random forest classifier n_estimators equals 100 class_weight equals balanced. CLF fit x_train y_train. 7. Model evaluation. Use metrics suited for imbalanced datasets. Precision, recall, F1, score. ROC-AUC. Peer UC. Confusion matrix. From sklern.metrics import classification_report, ROC_AUC_score. Y_pred equals CLF predict x_test. Print classification_report y_test y_pred. Print ROC-AUC score, ROC_AUC_score y_test, CLF predict_proba x_test, 1. 8. Model tuning. Use GridSearch CV or Optuna for hyperparameter tuning. Apply SMOTE or undersampling techniques to balance data if needed. 9. Model deployment. Save model. Use joblib or pickle. Create API. Use FastAPI or Flask. Host on cloud, AWS, GCP, Azure, or Docker plus Kubernetes. Create a dashboard, Streamlit, Dash, or React frontend. Import joblib, joblib.dump, clf, fraud_model.pkl. 10. Monitoring and feedback loop. Monitor. False positives/negatives. Model drift, data changes over time. Implement feedback from user-labeled data for continuous learning. Bonus, unsupervised approach autoencoder for anomaly detection. Autoencoders can detect anomalies without labels by learning patterns in normal transactions. From keras.models import model. From keras.layers import input dense. Input_dim equals x_train.shape 1. Input_layer equals input shape sadface input_dim. Encoded equals dense 14 activation equals relu input_layer. Decoded equals dense input_dim activation equals sigmoid encoded. Autoencoder equals model inputs equals input_layer outputs equals decoded. Autoencoder.compile optimizer equals atom loss equals MSE. Autoencoder.fit x_train epochs equals 10 batch_size equals 32. Optional, real-time fraud detection pipeline. Collect streaming data via Kafka or webhooks. Stream it into the model API. Respond in real-time with fraud or safe. Final deliverables. fraud_model.pkl. API endpoint/predict. Real-time pipeline, optional. Dashboard for visualization. Drop your questions in the comments and don't forget to like, share and subscribe for more AI project videos. Subscribe for more AI and ML tutorials.